Okay, let's go ahead and do 73. 73 says the chart below describes the speed of 4 desktop printers. So as you can see, the RoboPrint prints 2 pages per second. The Voltron prints 1 page for every 2 seconds. The Vantech Plus prints 160 pages in 2 minutes. And the DLS Pro prints 100 pages per minute. So the question is asking us which printer is the fastest. So let's go ahead and check this out. Now the first thing you should notice is that everything is in different time measurements. So for example, the last one's in minutes, the second to last one's in 2 minutes. The first one here is per second, this one's per 2 seconds. So we need to make sure we get all of this the same before we even start to compare. So there's a few different things I can do with this. I can either turn them all into seconds or all into minutes. I'd rather turn it into minutes because I think getting into seconds is going to be too hard, and you might get something like 1.2 or 0.8 pages per second, and we don't want to mess with decimals if we don't have to. So let's all turn everything into a minute. So for the first one, for the Robo printer, it prints 2 pages for every 1 second. And we know that there is 60 seconds in a minute. And we're going to make this into a minute. So how does 1 turn into 60? We could multiply it by 60. So what we do to one side, we have to do the other. 2 times 60 is going to be 120. So RoboPro or RoboPrint is going to print out 120. I'm going to write that over here so we can see it. And if in case you don't know what I'm doing here, it's simply cross product is what I'm doing pretty much, and I'll show you what I mean. So right here for the Voltron, it prints 1 page every 2 seconds, and we want to get that to print every 60 seconds because that's 1 minute, and of course we don't know what this is, so we're going to multiply 1 by 60, and then that's 60. Whoops, not 16. 1 times 60 is 60, and then we're going to divide that by 2, and that will give us x equals 30. So the Voltron prints 30 pages every minute, or every 60 seconds. Let's go ahead and do the Vantech Plus. Now the Vantech Plus, I don't really need to mess with it that much because it already has 160 pages in 2 minutes. We're going to change everything to 1 minute, so that's half of this. 2 minutes is half of 1, so I could just cut 160 in half or divide it by 2 like I did with 2 minutes, and that'll give me 80. And this one's already in minutes. It says 100 pages per minute, so it's already so in 1 minute, all these print out this many papers. As you can see, the clear winner here is the RoboPrint. It prints out 120 pages a minute, which is much faster than the other ones. This Voltron one prints really slow. 30 pages a minute, that's not very good. So as you can see, our answer is RoboPrint, so our answer here is A. Okay, problem 74 says the atmosphere normally exerts a pressure of about 15 pounds per square inch. So 15 pounds per every 1 inch. Okay, got that. At sea level. About how much pressure does the atmosphere exert on a surface of 30 square inches in area? So we're going to use cross product here. It says 30 inches and we want to know how many pounds. So all right, let's go ahead and do this. As you know, a cross product, we simply multiply the ones we can. We can't multiply 1 and x because we don't know what x is. So we got 15 times 30, or 30 times 15. That's going to give me 0, 3. That's going to give me 450. I'm going to take this number and I'm going to divide it by my last remaining number, which is 1. 450 divided by 1 is 450. So on 30 square inches, it should exert 450 pounds. So that's how you do this one. Cross product would be another good, would be the way that you want to do this one. There is another bit of an easier way, if in case you don't know cross product or don't want to do it. And I'm just going to rewrite the problem here. It's 15 pounds for every 1 inch, and we have 30 inches. but we don't know what this one is. Some of you have seen this. I know on simpler problems like this one, it's very easy to do. With 1 inch, all you have to really tell me is how 1 inch turned into 30 inches using multiplication, obviously because it's getting bigger. So 1 times what equals 30? Well, that's easy. It's multiplied by 30. 1 times 30 is 30 over here. So what you do to the bottom, you do to the top. And as you can tell, 15 times 30 is x, which is 450. So there's 2 ways to do this one. Cross product is still the best way to do it because your answer is always going to be right. All right, 75 is a utility company estimates that a power line repair job will take a total of 24 person hours. If 3 workers are assigned to the job, how long will it take them to complete the job according to the estimate? So it takes 24 hours of work to get this done for 1 person. So they say that 3 people are assigned to this job. How long is it going to take? Well, we know it's going to take a total of 24 man hours to do this. So our answer is going to be 24. Or our answer to our equation is going to be 24. And there's 3 people doing it. But what we don't know is how many hours each person has to work. So since we don't know how many hours, we're going to use a variable, which in this case is x. And actually, I'm going to not use x. I'm going to use h because that would mean hours. So now we just have to solve this simple equation. We obviously divide by 3. H equals 3 goes into 24 8 times. So it's going to take us, those 3 people, 8 hours each to complete the 24-hour job it would have taken for 1 person. All right, 76 says citizens of Honduras use lempiras for their money. In July 2002, the conversion rate for U.S. money to Honduran money was about 6 cents for every 1 lempira. What dollar amount was equivalent to 300 lempiras? All right, so let's find out. If 6 cents is equal to 1 lempira, then we're just trying to convert 300 lempiras to how many cents? I don't know, so I'm going to put that on top. This is another great way to do cross product. So we're going to go ahead and multiply 6 times 300. That should give us 1,800. And we're going to divide that by our last remaining number, which is 1. And 1,800 divided by 1 is 1,800. So our answer is 1,800 cents, but I don't really see that on here. Remember, this is 1,800 cents. So I'll put the decimal right here. 1,800 cents is the equivalent to $18. And so our answer is C. All right, number 77 says, what is the area of trapezoid QRST in square units? And right here, as you can see, it gives us the formula for area of a trapezoid, which is really nice in case we didn't remember it. It is one of the harder formulas to remember. So here's our trapezoid down here. As you can see, it's trapezoid QRST, just like it says. So now we have to use the formula. So the formula is A equals half of H. And as you know, H is height. There are 2 different kind of things that are kind of height here. We have this 4 right here. And we also have this 5 right here. So which one's the height? Well, as you can tell, the 5 is a little crooked. It's not exactly going straight up and down. That is not the height. Remember, the height is always going straight up and down when we're talking about math. So this 5 is really nothing. It's just there to distract us. So the 4 is our height. So half times 4. And then inside parentheses, we have B1 plus B2. If you remember, in our textbook, it changed from 6th grade to 7th grade. In 6th grade, it was B1 plus B2, which we know as base 1 and base 2. And for some reason, in a 7th grade textbook, we went over it, and it says A plus B. We just talked about how A is the first base and B is the second base. But I like this better with B1 and B2 because it's easy to understand that it's the base. So the bases are always going to be flat. So we're looking for the 2 flat parts, the 2 parallel parts of the trapezoid, which in this case are 8 and 11. So let's go ahead and put that base 1. It doesn't matter which one's the first base or the second base. I always try to be consistent, so I make the bottom one the first base. So 11 is the first base plus the second base, which is 8. All right, so now we're going to go ahead and simplify this as best as we can. So let's go ahead and start with doing any work in parentheses. We can do this work right here. 11 plus 8 is 19, still in parentheses. Then we have area equals 1/2 and 4. So now we have 1/2 times 4 times 19. So let's go ahead and do this. Half times 4, which is pretty much telling me half of 4 is 2. And 2 times 19 is going to be 38, I believe. Let me go ahead and check. It's always good to check your work and make sure you're doing it correct. That's 18. 1, that's 2, carry the 1, 38. Okay, I was right. So my area is 38 units squared, which means it is C. Number 78 says Sherry cut 4 congruent triangles off of the corner of a rectangle to make an octagon, as shown below. And the question is asking us, what is the area of the shaded octagon? Well, as you know, there is no formula for finding the area of an octagon. So we pretty much have to troubleshoot here. So what that means is we need to find out how we can find the area of this octagon. So as you know, it was a rectangle first, and as you can see, the rectangle, the corners were cut off. So I can simply do this by finding the area of the rectangle, the area of the whole thing. So I'm going to find the area of everything in here, every part of the triangle. I'm going to color it in as best as I can. And then what I do is I'm going to go ahead and find the area of these little triangles. Now they're all the same. So I'm just going to find the area of one and multiply it by 4. And what I'm going to do is then subtract it from this. So let's go ahead and get started here. So the area of a rectangle, we know the formula for that is area equals length times width. And for this one, we know that it is 9 times 16. And 9 times 16 is, let's go ahead and figure that out. That's going to be 54. Carry the 5. That's going to be 144. So 144 centimeters squared is our area for this rectangle. Now all I have to do is find the area for these triangles and then subtract them. So let's go ahead and find the area for the triangle. If you remember, hopefully you do, that the area formula for area of triangle is half base times height. So as you can see right here, the base, we'll just call this the base right here, is 2. So it's going to be half 2 times the height, which is going to be right here. Or we could have done it the other way, but they're both 2, so it's fine. Alright, so half of 2 is 1, and 1 times 2 is 2. So the area of the triangles are 2 squared, or 2 centimeters squared, for each one. And there's 4 of them, so I can multiply that by 4, and I get 8 centimeters squared. So I'm going to take my area for my rectangle. I'm going to move this aside right here. Oh, better move that. Oh, move that over there. And I'm going to take my area for my rectangle, which is 144. So 144 centimeters squared minus, because I'm taking away all these areas of these rectangles right here, or I'm sorry, these triangles. And that's going to give me 136. So 6, 3, carry that, 14. So the area for this octagon is 136 centimeters squared, or B. All right, number 79 says Alicia divided the staircase figure below in rectangles to help her determine the area. All measurements are in millimeters. Okay, so we got 5 millimeters here. So here's the staircase. Now, as you can tell, it's broken off. It progressively gets higher. So the thing we want to look at here is defining the area. Obviously, there's no formula for an area like this. But what we can do is find each piece at a time. So for example, there's a number of different ways we could do this. We can find the area of this shape in here first. And that should be easy to do because, as you can see, it's 5 by 5. So we'll just use area of a rectangle, which is length times width. And we'll go ahead and multiply 5 times 5, which is going to give us 25. So my area for that shape right there is 25 millimeters squared. So I'm just going to write 25 right there. Now, as you can see, if you can tell in this staircase, there's a lot of these little squares in here. That might be one way we can do it. So let me just go highlight some of the squares so maybe you can see what I see. So as you can see, every one of these cubes is 5 millimeters, or 5 by 5 millimeters. So each of them equals 25 millimeters squared. So just like the other one. So I'm just going to go ahead and label all of them 25. Another way I can do it is I can measure how many there are here. So for example, if this is 5 down here, then this is 5 right here, this is 5, this is 5, this is 5. So this would be 5 times 20, which is going to give me 100. And I know it's 100 because 25 plus 25 plus 25 plus 25 is 100. So there's a number of different ways to do this one. It's pretty easy if you just sit down and try to do this one on your own. So it's a good exercise for doing different kinds of area. So let's go ahead and add these up. We got 25, 50, 75, 100, 175, 200, 225, and 250 if you add up all the 25s. There is 3, 4, 5, 6, 7, 8, 9, 10 of them. So we're going to multiply by 10, and that gives us 250 millimeters squared, which means our answer is C. Okay, 80 says, what is the volume of the rectangular solid below, shown below? So as you know, the formula for volume is volume equals length times width times depth. So what we're going to do here is do length. We got 2 times width, which is 5, times depth, which is 3. So this equals the volume. So 2 times 5 is 10. 10 times 3 is 30. So we got 30 inches cubed. Remember that volume is cubed. So let's see, that would be C, 30 cubic inches. 81 says Jason is 72 inches tall, which measure does not describe Jason's height. Okay, so he is 72 inches tall. So first one says he is 6 feet. Okay, so let's see if he's 6 feet. If he was 6 feet, we know there's 12 inches to every feet. And so we're going to multiply it by 6. And we should get 72 if that's correct. So carry that. And sure enough, 6 feet is 72 inches. So it says it's not correct. That one is correct. So I'm going to go ahead and cross that one out. I also know that 6 feet is also 2 yards. Remember, there is 3 feet in every yard. Now, I could determine whether 72 inches is 182.88 centimeters, but I am focused more on B, on our answer B. And the reason is because we already know, and I'll go ahead and erase this right here so you can see it. We already know that we crossed out B right here, or A right here, because we know 6 feet is 72 inches. So look right here at answer B. It says 7 feet. So can it really be 7 feet? I mean, it's pretty obvious that if 6 feet is 72 inches, it can also not be 7 feet and 2 inches. So right away, I know that's a dead giveaway. B is the right answer. 7 feet is going to be more than 72 inches. So it's not B. I didn't even have to convert inches into centimeters for this one. All right, 81 says, look at the coordinate grid below. All right, it says points R and S will be added to the grid. So right now you see P and Q. Obviously R and S are not there. We're going to add them. They're going to be added to form a rectangle PQRS with an area of 20 square units. Which ordered pair could be the coordinates of R and S? So what I have here essentially is 2 points that are going to be part of a rectangle, but they're not a rectangle yet. So let's go ahead and see what we have to do to make it a rectangle. Now, it says that a rectangle is 20 square units. So that means that that's the area of it. So the area equals 20 units squared. And all we need is the length and the width. So do we have either one of these? Well, we have one of them. It looks like we have the width here because this is either the bottom or the top of the triangle. It doesn't really matter which one it is. Actually, it's probably the top because it's going to start off with rectangle PQ. So that means it's starting off right here at the top. So let's check this out. Let's see how long this is. So we got 1, 2, 3, 4. So it looks like the top is 4 units long. So the width is going to be 4. So what times length times 4 equals 20? What times 4 equals 20? Well, that's easy. That's 5 times 4. And I know 5 times 4 equals 20. So that looks like that's going to be my answer. So what does this mean? What does it mean that I have this 5 now? That's obviously my length. Well, it means that from here, from point P and from point Q, we know how far we're going to go down now. We know we're going to go 5 units down. So 1, 2, 3, 4, 5 right here. And 1, 2, 3, 4, 5 right here. And this gives me my rectangle. And if you count all the squares in here, it should be 20 because it's 20 units squared. So the question's now asking which ordered pair could be the coordinates of R and S. So R and S are right here at the bottom. R, S. And we want to know the coordinates for them. So the coordinates for R is, it looks like it's on 5, 5x, and negative 3, the y, and the coordinates for S are 1 and negative 3 as well. So it looks like C is our answer. 83 says in the figure below, D is the midpoint of line AC, and BD is perpendicular to line AC. So remember, there's a few keywords here. First of all, midpoint. It says D right here is the midpoint of line AC. That means D is exactly the middle. And the reason it's telling us that it is exactly the middle is because it's saying that each of these is 15. And why does it say 15? Because right here it says 30. And it tells you that D is cutting each of these triangles exactly, this bigger triangle, in half. So each of these triangles on the side are equal to each other. So that's why it's telling us that this is the midpoint. Now it says line BD is perpendicular to line AC. And that means that they meet at a 90-degree angle, which means that there's no hidden angles or anything that we have to worry about. So what it's telling us now is what is the length of BD. So BD is right here. As you can see, we do not have a measurement for that, but we do have a measurement for the other two sides of the triangle. Now this is a right triangle, as you can tell by the right angle symbol right here. So in right triangles, we can use the Pythagorean theorem to solve for the missing side. So the Pythagorean theorem, as you know, is a squared plus b squared equals c squared. So remember, a and b are both legs, and c is the hypotenuse. So let's go ahead and find the what we're missing here. So remember that the legs are connected by the 90-degree angle. The legs are touching the 90-degree angle and the hypotenuse is not touching it. So we know right here that 15 is one of the legs. So I'm going to make that A. Really doesn't matter whether I make it A or B. B, the other leg, which is right here, it's my green highlighted line, is the one I'm missing. So I'm going to call that X. Actually, I'm going to call it B because I'm going to go ahead and leave it what it is. And it looks like C right here is the hypotenuse. So the hypotenuse is 25, and we're going to square that as well. All right, so here we go. 15 squared is 225 plus B squared. And 25 squared is 625. So I'm going to go ahead and solve for B squared right now. I'm going to try to get B by itself. And it looks like B squared equals 400. So I have what B squared is, but I don't really want to know what B squared is. I really want to know what B is, because B is the length of this missing side over here. So I have to get rid of this square. So in order to get rid of a square, in order to get rid of anything, you really have to do its opposite to it. So the opposite of a square is, of course, square root. So I'm going to go ahead and find the square root of B squared. So in other words, I'm trying to find out what two things multiplied, I'm trying to find out what same letter, number, or variable multiplied by itself equals B squared. And we know that that's B. So the square root of B squared is B. Now what we do to one side, we have to do to the other. So that means I have to find the square root of 400. And I know that the square root of 400 is 20, because 20 times 20 is 400. So it looks like my answer is D, 20 centimeters. 84 says, what is the length of line YZ? So this is another Pythagorean problem. So let's go ahead and go highlight this so we know what we're looking for. Remember the Pythagorean theorem, it's a squared plus b squared equals c squared. It's one of my favorite formulas because it's easy to remember. So remember now, a and b are the legs, c is the hypotenuse. So how do we find the legs? The legs are connected to the 90-degree angle, which this is the leg right here, and this is also a leg right here. So it looks like we are missing another leg. So I'm going to go ahead and make 8 one of the legs. We are missing b as the leg, and the hypotenuse right here is c, and that is 17 squared. All right, so 8 squared is 64 plus b squared. 17 squared is 289. So I'm going to go ahead and subtract 64 from here, minus 64. I'm left with b squared equals, I see that's 5 to 225. So I just had this problem. I thought I just saw something equal 225. So like I said, we need to get rid of the square. The way we get rid of the square is we use its opposite. The opposite of a square is a square root. That's going to give me b down here. And the square root of 225. What two numbers multiplied by each other equal 225? Well, I know that the square root of 225 is 15. So it is in centimeters though. So my missing side is 15 centimeters. I can go ahead and circle this right here. Now, just in case you didn't know what the square root of 225 is off the top of your head, you can go ahead and figure out all the square roots out by going ahead and multiplying these numbers. So if I didn't know what if it was 9 or not, I would do 9 times 9, and that would be 81. And 81 does not match with 225, so I know it's not 9 centimeters. But 15 times 15 is 225, so that's how I know it is B, 15 centimeters.